The directions for number 30 says solve the system of equations using an algebraic method. So using algebra, I should just put this here. Using algebra, we want to find what specific x and y value could I plug in, and the left side would equal the right side for both equations. Or if you're a visual learner, it's like finding out where do the two cross. Remember, wherever they cross has both an x and a y value. So here's the first thing we're going to do. We're going to isolate the y's in both equations. So to isolate the y in the first, I need to move the x over. So if y equals 3 subtract x. I'll do the same thing in the second. Y equals x squared plus 4x. I'm moving that 3 over. It's a minus 3. Once I have y equals for both, so I just rewrote it, now I'm able to take these two portions, set them equal to one another to solve. Please make sure that all earbuds are out of your ear, even if you have no music on. So there's no rule right now that says I need to move things to the right or to the left, but there's always a strategy that makes it easier. And so I'm finding the degree, which is on the right here. It's 1x squared. This is the largest degree. And because it's positive, I'm going to move everything to the right. So I'm going to add the x over and subtract the 3 over. 1x squared plus 5x minus 6. As I spoke about earlier today, when you're asked to solve for x, you have a few different methods. Sometimes factoring works. When factoring works, it's the fastest. Quadratic formula and completing the square will always work in every circumstance. I'm going to try factoring. Is it possible? Well, 1 times negative 6 is negative 6. I'm looking for two numbers that multiply to get equal negative 6 and combine to equal a positive 5. So I'm going to write down all the combinations. 1, 6, 1, 6, 2, 3, 2, 3. So they have to be different signs. So negative, 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 negative. One by one, I'm going to look at my combinations to see, do any of these equal a positive 5? Negative 1, the very first one works. Negative 1 times 6 multiplies to equal negative 6, and it combines to equal positive 5. What do I do here? So I have 0 equals x minus 1 and x plus 6. And I don't have to worry about taking the leading coefficient and dividing because it is a positive 1. Remember, this lies to us. One answer is 1. It lies to us. The other answer is negative 6. If you stop here, you're only going to get 50% of the work. Because remember, where they cross, every x has a partner y. Every x has a partner y. So I have the x values, but I need to know what are their partners. What are the y values associated with each of these x's? So you go back to the original equations, whether you use these top two or how we rewrote them, and you choose whatever equation looks simpler to work with. And I think the top looks simpler. So I'm going to use this one. And you can do mental math, you can use a calculator, you can write it down, whatever works for you. So I'm going to substitute in 1 for an x. 3 minus 1 is 2. Then I'm going to substitute in negative 6. Oh, that's a little tricky here. I'm going to write that out so I don't make a mistake. 3 subtract negative 6. 3 subtract negative 6. Well, two negatives make a positive, and I end up with 9. How can you verify that this is correct? How can you verify that these two functions intersect at 1, 2 and at negative 6, 9? There is an easy way. Plug these both into Desmos, and they should cross at two places, specifically 1, 2 and negative 6, 9.